for the introduction and the kind words. I appreciate it. And today we're going to do a bit of a survey. Since we only have an hour and I want to do some Q&A at the end, we'll spend about 45, 50 minutes talking about a variety of blockchain topics. We won't be able to go too deep, but hopefully we'll give you guys some general idea. A lot of my work is around cryptocurrency trading and technology. My PhD, as he said, is in stats, but I always liked financial engineering. And for me, the combination of risk, finance, probability models, data, and technology are all really interesting and are all skills you can pick up in this kind of department. And you can combine them in lots of ways. You don't just have to do epidemiological analysis or basic stats models. You can take those skills into a lot of different business use cases. I like to work backwards, as you mentioned. What's the problem? What's the goal? Okay, which pieces do I need to take? What do I need to learn and get a solution? And hopefully here you guys can have access to a lot of those tools to build your tool set. So as I mentioned, today we're going to talk about some of the mechanics of blockchain and give you guys an idea about just what this thing is. I'm sure if you Google blockchain, every newspaper and blog and magazine has some really cool looking picture like this with lots of ones and zeros and sexy numbers. And you'll read things, blockchain is changing the world, blockchain is democratizing finance, blockchain will cure global warming, it will end poverty, all this nonsense. Blockchain is a database, and it's a very simple database. It's actually rather slow and rather inefficient and rather difficult to use. So why do we use it? We use it because it's decentralized. Traditionally with a database, you have some single authority or some single company or source of truth on that data. Maybe you don't trust them. Well, the nice thing about blockchain and the whole advantage is everybody shares the data and it's verified in this communal way, so you don't have to trust anybody. Now, when people always show me proposals for business plans or new businesses they want to start, inevitably it has either AI or blockchain in the business plan now. And my first question is, if we delete the word blockchain, do you still have a viable business? Do you need this blockchain? And there's a pretty simple test. Do you have multiple people accessing the data? Do you have multiple people writing the data? Is there a trust issue with the people sharing the data? Often there isn't a trust issue, or you don't have many people writing data, so then you don't need a blockchain. So things to look at. Just because you see blockchain does not mean it's magic. Now, there are two kinds of blockchains in the world. In general, there are new ones coming out all the time. In fact, if one of you wants to do a PhD thesis on this, you could probably develop your own blockchain. The two main ones are what's called a UTXO model, and an account model. And we'll dive into the details of both of those in the next few slides. In general, UTXO model is kind of like an acyclic graph, where each transaction and each amount of funds follows a graph pattern. And an account model tends to be like a state table. We have a state of the world, and then there are updates to the state, and they happen atomically. Now, before we get into that, there are a few core concepts you need to understand. And all of these we could do a deep dive, and if I wind up teaching a course here, we'll spend more time on them. They are hashing, public key encryption, transactions, blocks, genesis, and mining. And then at the end, let's talk about some challenges and opportunities that might be interesting to you. So hashing is a key thing, and I mentioned this briefly in the last talk, but hashing is a kind of digital fingerprint. There are many algorithms, and you can take a piece of data from 1 byte up to millions of gigabytes of data, run it through this algorithm, and you get back out this number, which is a combination of letters and numbers. It's in something called hexadecimal format. Is anybody here familiar with hexadecimal? Okay, none. All right. Traditional counting system, we have 0 to 10, right? 10 fingers, people count from 0 to 10. In the computer world, everything is binary, 0 or 1. So everything's based on powers of 2. So what's convenient is you have 2 to the power of 8, I'm sorry, 2 to the power of 4, and you wind up with 16 numbers. You have 0 through 9, and then A through F. And it lets you represent binary numbers in the computers in a short, compact way. So this is just a really, really long integer being represented in a compact way. Now, what's interesting about these kind of checksums is they're like a proof. They're exact. Here's a standard English sentence. Change one character, you get an entirely different output. Change a different character, another entirely different output. So if I have this checksum, I don't need the original data. Anytime in the future, I can run the data back through the same algorithm and make sure I get the same value. You change one piece of that data, one letter in an entire book, or one letter in an entire library of books, there'll be a different outcome. So to be efficient in the blockchain world, people often just store this. They're just storing the proof of what the data is. If you want to verify, you can always pull the original historical data back out somewhere else and check the proof, but it saves a lot of space and time to just store the proof. So this is hashing, and it's used all over the place in the blockchain and cryptocurrency. It's one of the core concepts. The other really important concept is something called public key encryption. Anybody familiar with this one? Okay. How many of you, when you go to your browser or your online banking, you see the address is HTTPS, right? Anybody ever notice? A couple. Okay, the S stands for SSL, or Secure Socket Layer, and it's actually using this kind of encryption. Public key encryption is interesting. In the old days, I would have a password, I would encrypt some data, give it to my friend. They would need to know the same password to decrypt the data to read it. You know, think like in the old spy movies, they had to share the little password or the little key. But that's really inefficient. So a long time ago, a bunch of mathematicians have worked out a system where you basically have your password, or they call it a key, and you tear it in half. There's a public half and a private half. What's interesting is I can use the private half to sign things and encrypt things, to prove it comes from me, and to scramble the data so no one can read it. You can then use my public key, which I can put on the internet, I can share with everybody, there's no security issues at all, to verify that I really signed it. And the nice thing is, if you have my public key, it is literally or probabilistically impossible to know my private key. So it lets me sign something or scramble something, show it to the world. Everybody can know it came from me, but they can't impersonate me. They can't fake my data. Why that's useful? I'm going to pay 10 Bitcoin to the stats department. How do you know it came from me? I signed it with my private key. Can always prove it came from me. If somebody else claims I gave them my Bitcoin, they're lying because it wasn't signed by my private key. So these keys are the other really important thing to all of the cryptocurrency. And if you keep hearing about cryptocurrency exchanges getting hacked and funds getting stolen and wallets getting hacked, inevitably it's the hackers finding some clever way to get this. Because if they get this, they have all your money. Banks use this for all their encryption. Most of the apps on your phone with data are using some version of this. It's behind everything. Many things are user-friendly, so you don't see this happening, but this is what's going on behind the scenes. So we have hashing, we have public key encryption. And we're going to cover why those are both important in the next few slides. Now, the first blockchain to come out came from Bitcoin. It was published in a paper by Satoshi Nakamoto, which is an anonymous pseudonym for either a person or a group of mathematicians, no one's sure. But they wanted to solve the problem of how do you verify this digital money efficiently? If I'm going to give you one Bitcoin, well, the first question is, well, how do you know I have it? Well, I got it from my friend Bob. Well, where did Bob get it? Bob got it from Joe. Where did Joe get it? Joe got it from Mary. Well, if you have millions or billions in transactions covering 20 years, every time someone spends $1 to buy a coffee, you can't trace it all the way back to the beginning of time. That's impossible. Well, not impossible, but it's horrendously inefficient. It might take a week of computing time to trace each dollar. You can't. So what they did is they came up with a very clever idea. How do you summarize? You can take a batch of transactions, summarize them together, and then calculate the checksum and use that going forward, and that creates a blockchain. Now, the first kind of transaction they did is what they called unspent transaction output. And again, we could do a deeper dive on this when we have more time, but in a sense, a transaction has really two things. It has an input and an output. This example has one input and two outputs. So I'm saying I'm putting in 100,000 Satoshi, which is a fraction of a Bitcoin, and out of it, 40,000 go here and 50,000 go here. So it's like a graph. Put in the output of one transaction becomes the input of the next transaction. And then the output of this one becomes the input of that one. This creates your chain, if you have the concept of blockchain. So why do we know this guy has 10,000? Sorry, he has 20,000. Well, he got 10,000 from here and 10,000 from here. How do we know he had 10,000? Well, he got 20,000 from here. How do we know he had 20,000? Well, he got 50,000 from here, and so on. So everything, a transaction is just an input and an output. It doesn't have accounts, it doesn't have names, doesn't have timestamps, it's just input and output. But as you see, you can build an entire network of these and have billions of transactions and everything is traceable. Now, a transaction to give you guys an idea, and again, there's no exam on this, so don't worry, is you have the hash. If you remember, we talked about that hash at the top, which also becomes sort of like the ID of the transaction, because no two transactions will ever have the same hash. The input, this is the hash of some transaction output number 2, and this is the value. It also has output number 0 from another transaction and its value. The other interesting bit is this thing called a script. A script is basically like a little puzzle. It says, okay, in order to spend, this guy is claiming I got 50K from here. How does he prove it? Well, he needs to use his public key encryption to sign it, and he has to have this key. So basically the transaction is saying, I'm publishing to the world, there's an output, only the person with the private key matching this can spend it. You don't have to know who the person is, you don't have to know when they spend it, it doesn't matter. Their private key has to sign matching this public key to claim this value. Does that make sense? It's a bit messy, but it's the original Bitcoin model, and it's why it's called the unspent transaction output. You're claiming unspent transactions. Once you've spent them, you can't claim them anymore. Now, account-based is much simpler. This was what was invented for the Ethereum blockchain. Anybody heard of Ethereum? Okay. So Ethereum said that's too messy. We're just going to give everybody an account. And your account has a balance, and we have what's called a state machine, which is the state of the world, everybody's account balance right now. The blockchain jumps to the next block, transactions happen, everyone's account now has a new balance. And so it's much, much cleaner to just look up the balance of an account instead of tracing through all these transactions. But you still need a blockchain, and you still need all the cryptographic stuff to verify that the account balances are what they say they are. And if I'm transferring one Ethereum from my account to your account, I still have to prove that I have that Ethereum. So the state still needs to update. Now, the other interesting part is Ethereum was designed as what's called a state machine. If you're in the computer science department, you might study some of that. They won't touch it in the stats department. They decided that while you're updating the state of the world, well, the computers can do a little work. Instead of just adding up account balances, why not have some more things happen? So they created a very simple programming language. It's a little bit different than R, but if you know R or JavaScript or some Python, it's not that hard to learn. And it's called Solidity. Solidity is compiled into sort of a machine code, and that runs in the blockchain. So you can send little tiny pieces of computer code to do work in addition to transferring money. And that becomes really interesting. That's what launched the entire cryptocurrency bubble that you see today, and all of the trends and all the games and NFTs and decentralized finance and central bank stable coins and everything you're seeing all comes from this concept. So when you send a transaction now, you're sending a message, and you're sending, they call gas or petrol in British English, that I will explain in a minute. The Ethereum virtual machine does a little bit of work, and then it updates the state of the world. And the blockchain turns about every 15 seconds. Now, the Ethereum virtual machine is important, so we want to talk about it from another slide. This one, we're going to talk about gas. When you send a transaction to do anything, whether it's just transferring money or doing some incredibly complex financial mathematics or derivatives, you say, I'm willing to pay this price per unit of gas, $10 per liter of petrol, and I'll spend up to this much gas, I'll spend up to 10 liters of petrol to do something. The machine starts to do the work. Every line of code or every instruction you ask it to do has a cost of gas. If you run out of gas, if you didn't send enough gas, your transaction doesn't happen. It just dies in the ether and you've lost your gasoline. It's imagine if you put enough gas in your car to drive to, I don't know, Saikung, and you run out of gas halfway through, okay, you're stuck. Same idea. You need to always make sure you save gas to make the transaction happen. The reason there's gas is twofold. One, without any limits of gas, people could abuse this computation system and pump tons of transactions through and run all their own code on it at no cost. And spammers would do all sorts of messy stuff. And two, people mine the blockchain. I'm sure you've heard of Bitcoin mining and Ethereum mining. The gas is the money that's paid to the miners. So you're incentivizing an entire network to mine the blockchain, and mining is just verifying the transactions. So now the people verifying everything and making sure everything is added up have an incentive in the form of gas. So it's a nice double benefit. Now, we're going to talk more about the Ethereum chain because it's more interesting than Bitcoin these days. We have the state of the world, right? These are, you can think of these as account numbers, right? It's that same hexadecimal thing. It's just a hash like we talked about earlier. You have a transaction that can spend money, do things, ask for computation, there's sort of no limit. And then you have a new state of the world. So the state happens in chunks. Every 15 seconds, the state of the cryptocurrency world updates. And all of the transactions happen simultaneously in that one chunk. So there's usually around 200 transactions per block. So every 15 seconds, 200 transactions happens at the same time. Money transfers, code is executed, account balances are updated, all simultaneously, 200 in a chunk. That's given rise to some interesting things, something called an ICO. Anybody heard of those? It stands for initial coin offering. One of the things you can do with the blockchain is you can create your own cryptocurrency, create your own token. There are hundreds of tokens created every hour. Most of them are junk. Many are scams, but anyone can create one. And so people play a bit of a marketing game and say, oh, we're launching our new token. It will go on sale Monday morning. Let's get a bunch of marketing hype. Let's convince everyone to invest. And they launch it. And maybe it's a real company. Maybe it's just a BS scam. The next evolution was something called an STO, which stands for securitized token. Companies basically treated it like stock or shares. If you're familiar with Listco on the Hong Kong exchange, now they're saying, oh, we're offering shares in our company, but each one will be a token on the Ethereum blockchain. And because you can write this little piece of computer code, you can have the rules for how people can buy and sell the shares of your company built in, and then you can offer these shares as tokens. The other big bubble, which I'm sure people are seeing now, are non-fungible tokens. Anybody here heard of NFTs? A few people? Okay. Non-fungible is an interesting concept. Traditionally, one Ethereum is one Ethereum. We touched on this briefly last time. The tokens don't matter. They're all equal value. That's the definition of the word fungible. $1 is the same as any other dollar. Nobody cares. Non-fungible means each one's unique. My dollar has a serial number on it. It's special. It's got a bunch of 8s in it. It's worth more than $1. It's not the same as yours. Or I have a rare comic book no one else has. It's worth more. So people came up with a way to use this blockchain state machine and have tokens that are different. So now people collect them and trade them. Often you'll see them tied to artwork. You're starting to see them tied to games. You're seeing them tied to real estate or the registration for your car. At some point, your Hong Kong ID could be one because each one's unique. And the blockchain is a really good way to keep track of who owns what and who's transferred what to whom in a very trustworthy way. Those led to game tokens. Now, a lot of video games, things are being tokenized. One interesting project I saw, there's a company that's working with PlayStation and Xbox and a few others. And the idea is if you have some asset in the game, I don't know, a sword or something, it's a token and you can take it to different games because on the blockchain, it belongs to you. So now you own it. It's not just something you have in the game, but it's actually your asset on the blockchain and you can sell it to somebody, you can rent it, you can use it around different games. You have a real asset in the game. And the other big bubble is something called decentralized finance, or DeFi is abbreviation. Again, because of this little virtual machine computer, you can have rules. So people have worked out things like currency exchange. I want to trade Ethereum for Bitcoin. What's the exchange rate? Why not have the computer and a little bit of AI or what they call a smart contract do the exchange for you? I want to borrow some Bitcoin to do some trading idea. There's a contract for that. I can do it on the blockchain. I want to deposit some money and earn interest, just like a bank account. Well, someone wants to borrow. So again, you can use this state machine to track all that. People are now building all sorts of interesting and complex financial derivatives, all running on this type of state machine and virtual machine. I'm actually doing more and more work on data analysis from this and developing algorithmic trading strategies from this. Too deep to go for this talk, but if anyone's interested, happy to chat about it later. Now, as we talked about, we have this state of the world that gets updated. And this is just a nice graphic of kind of how the blockchain works. Anybody can plug in a PC. We could stick one in here, say, I want to be connected to the blockchain network. It's called a node. You run some software, and you'll have a full copy of the entire state of the world and the full blockchain running on your local machine. I have a few in my flat. You can do it on a very small, simple PC. And what this means is you're now participating in sharing that data. And more importantly, you have your own copy of all the data that's 100% accurate. There are no errors because the blockchain self-verifies. So not only are you participating, but if you want to do any kind of analysis, whether it's just for a stats project or for trading or anything else, you have your own participation in the network. Now, something interesting I want to touch on briefly, and it's a tangent we could go to further if there's some interest, is the order of these transactions. Remember we talked about transferring money between account A and account B. The order is not really, I wouldn't call it non-deterministic, but it's not fully deterministic. The blockchain, if you remember, updates every 15 seconds. So what happens in between? So if I want to send Ethereum to my friend and somebody else wants to call a smart contract and somebody else wants to send me some Ethereum, all those transactions basically sit in a pile in the cloud. The miners whose job it is to verify choose the order they want, and they choose them based on who's going to pay the most gas. If you remember, we go back a few slides, right? Then costs gas. So if I'm mining, if I'm verifying transactions, I'm going to verify the ones that pay me the most money first. And the ones that pay me a few pennies, I don't want to verify. They're not worth it. So you wind up with different miners possibly ordering the transactions differently. Now, why does that matter? Why do we care? Well, if you're a trader, if I'm buying one asset at a price and I'm selling it to make some profit, well, it may not happen in the order I want. It might happen in the wrong order and I could lose money. Some really clever people are starting to look at this pile of transactions and think, oh, I've got 15 seconds. I can offer a lot more money to the miner and they'll do mine first. So I can jump to the front of the queue. So now I can steal other people's arbitrage or other people's transactions before they happen. And there's a lot of really interesting stuff happening in that 15-second gap. It's this huge fight in software and offering bribes and gas to the miners because the transaction order is not, it's deterministic, I guess, based on gas price, but that's always changing in real time. Now, I've talked about mining and we've talked about blockchain. Briefly, what's happening when we talk about this 15-second update and this blockchain update? You have a block. What they do is you take a series of transactions up to a fixed size of data, and you do that big checksum we talked about earlier, that gives you that nice summary, and you add a random integer to the end, and you calculate the checksum again. And the reason you add the random integer is it's essentially a lottery. Millions of people around the world want to mine that block and collect that gas. Only one person gets it. So how do we decide who gets it? Well, there is a bit of an algorithm. You can ignore most of this detail. It's probably technical. But nonce just means n once. It just means computer slang for selecting an integer. And the reason you want to do that is you're looking for a checksum that ends in a certain number of zeros. Let me go back to this slide. This starts with 8FD8. This starts with FCD3. This starts with AC8. So what you want to do, or the miner does, is you verify every transaction in the block, do all this hashing, which takes some computing power. Then you add the integer 1, make the checksum. Does it start with a 0? No. Okay. Start again. Add the integer 2, take the checksum. Do you get a 0? No. And you do it until you find one, you randomly get one of these that has a 0. And there's no way to know ahead of time. And the reason you do that is it's called proof of work. I know you've had to do many rounds of verifying the data before you're lucky enough to get a 0. And as more and more miners compete, they make it harder. It says then it becomes you need to start with 2 zeros, or you need to find an integer that starts with 3 zeros or 8 zeros. And it becomes an incredible amount of computing power. And you do that, the software updates so that the blocks don't mine too fast, right? You want them every 15 seconds. And it really becomes a lottery. You don't know which of these miners is going to get lucky and find the one with leading zeros first. So you wind up with thousands of people constantly verifying all the same data over and over and over until someone gets lucky enough to find the leading zeros. It's called the difficulty factor. And the reason that happens is you know that lots of people are competing to verify the data. so that nobody can cheat, because you don't know, it's probabilistic. You don't know who's going to get it. Fun, I did this morning, very, very simple version. I said, this is a programming language called Go, if anyone knows it, but it's simple to read. I said, okay, let's loop through 100 million integers. The data is going to be Hong Kong University plus the integer at the end. So Hong Kong University 1, Hong Kong University 2, etc. Find me at least 3 leading zeros. Took 16 million. That was the first one I found with 3 leading zeros. This one actually had more than 3. I got lucky. But if you needed 5 leading zeros or 50 leading zeros, you could go through billions of these. My PC would be cooking for the next year. And that's when you hear about mining. There's specialized hardware. People are burning special computer chips. They're investing in big data centers, all to just try doing this checksum to find leading zeros. Because if you find it, you get the prize of the gas plus some other Ethereum that comes out of the network. So it is profitable. But the key is the data is being verified millions of times by millions of different parties. So we're all very comfortable that the results are correct. And again, there's a financial incentive for it to happen. Now, this has led to an interesting dilemma. A lot of people started complaining that the blockchain is not energy efficient. You even hear people screaming about global warming and that it's wasting electricity and that it's hurting poverty, again, all the negatives, because it's what's called proof of work. Why is it proof of work? Well, my computer had to do billions of transactions to hopefully get some of those leading zeros. So I'm just wasting electricity, just recalculating the same stuff over and over. And it uses a ton of computing power. So there's an alternative system people have talked about, which is very controversial, called proof of stake. And it's a probabilistic model, which in a sense is appropriate for this department. Proof of stake says you deposit money into the blockchain. You basically lock your funds in escrow. The more money you deposit in escrow, like depositing in a savings account in the bank, the higher your probability of getting that winning block. So you have to do less work. So the people that put up the most money have to do less work. They have a higher, it's still not guaranteed they'll get it, but they have a higher probability. Now, many people have complained in the sense that now the rich are going to get richer, because if you can afford to deposit a bunch of money, then you'll make more money, so you can deposit more money and you'll cut out the little guy. Other people's counter is, well, it saves a lot of electricity because the really rich guys don't have to do much work to mine the next one. So there's a lot of inner fighting in the cryptocurrency communities, whether proof of work or proof of stake is better. There are lots of new blockchains that try to find some balance between the two. I'll leave it to you to decide which one you prefer. And that leads us to some challenges. These are current issues in the cryptocurrency world that are open for discussion and people fight about. And if you want projects to do as a grad student, there's a lot of work to do in this space. One is transaction speed. If you remember, the Ethereum blockchain updates every 15 seconds. The Bitcoin blockchain updates every 10 minutes. So if I want to go to Starbucks and I want to buy a coffee with my Bitcoin, the cashier doesn't want to sit and wait for 10 minutes. Well, I hold up the queue waiting for the blockchain to confirm that the 30 Hong Kong dollars I gave them in Bitcoin is really my 30 Hong Kong dollars. So there's been a lot of work on trying to make it faster. The problem with making it faster is when you start to do this kind of thing, right, and this kind of looping and difficulty factor, there's a conflict. How do you have all of this really secure, repetitive verification of data when you have a time constraint and you want to go quickly? So people have worked out a lot of really creative shortcuts on this and new math models, and there's something called the Lightning Network in Bitcoin. There are Binance, which is a big Chinese blockchain company, has a faster blockchain that mines every 3 seconds because they've limited who can be a miner, and there's debates about whether that's better or worse for the community, but there's a variety of solutions. The other challenge people look at is what's called block size. If you remember here, right, there's a fixed number of transactions that go into a block. So there's been a lot of debate. Should we have faster, smaller blocks with 20 transactions in them, or should we have thousands of transactions in a block so that it's that makes the gas price cheaper and everything slows down a bit, but it's better for the community? Nobody knows the answer, but people are working on it. Right? Unexpected centralization. And this is a very real problem in cryptocurrency. Some huge percentage, I'd posit probably 90% of these cryptocurrency projects run in the cloud. They're running on the Amazon cloud. or Microsoft Azure Cloud, or Google's Cloud. There's three big ones. Alibaba has one, but no one uses it yet. So all of this decentralized finance, if most of it's just running the Amazon cloud, well, if the Amazon data center goes down or some government agency pulls the plug, well, you are centralized. All of this decentralized stuff is kind of worthless if it's all sitting in the same data center. So it's become a real issue, right? The other one, which is worth mentioning, is something called a mining pool. If you remember, we talked about, again, this thing, right? All the miners are competing. So people got smart. If I do this for Bitcoin on my high-speed machine, I might get a block once a year, if I'm lucky. Well, that's not very profitable, and it's not very reliable as a business. So people made teams. Hey, if 1,000 of us team up, all our computers will be mining. We'll keep track of who did how much work, and we'll just split the money. And so now you have these mining teams with 10,000, 20,000, 50,000 people in them, all sharing the work. Well, that's great, except you've now centralized what's a decentralized process, because everyone's splitting the money and sharing the work. And there's all sorts of ways that the data can be corrupted or dishonest things can happen. So even though it's a decentralized system, between centralized data centers and mining pools, things are becoming centralized again. So again, there's a lot of work there. There's a lot of opportunities to innovate new things. People are trying to come up with more fair systems, and there's a lot of interesting models and graph network models on better ways to do that. As we mentioned earlier, there's proof of work versus proof of stake. What's a better way to mine, and what's, it's a trade-off of green energy, global warming, efficiency, costs, versus rich getting richer and taking things away from other people. There's a debate on that as well. There's a big issue with fraud. Currently, one of the biggest problems is that people can launch their own cryptocurrency in about an hour if they know what they're doing, and they can market it and hype it. They can sell a bunch of it and run away with the money. Happens every day. People can create bogus blockchains where you think you're building up some huge bank balance. When you go to withdraw the money, it's not really there. Because it's such a new industry and because it's decentralized and a lot of it's anonymous, there is a lot of fraud happening. You need to be rather careful. There are issues with government regulation and oversight. Some cryptocurrency people think, no, anarchy, we should be free to do what we want. It's just, we trust the software. Code is law is something you'll hear, as in computer software is the law, and we don't need any regulation. But then, of course, the government, which controls the economy, and banks and finance companies want regulatory oversight, and they want to have some transparency into this, issues with money laundering and crime and all that stuff. So there's an ongoing debate, and you're seeing the world split in two, where a lot of financial systems won't touch cryptocurrency, and other financial systems are cryptocurrency friendly, but then they don't play well with the existing banks and governments. Some whole countries like El Salvador have legalized it. Other countries have made it, like China have made it completely illegal. So it depends on your perspective on that, but there are some challenges there. And then anonymity is a problem. Some people believe cryptocurrency should be completely anonymous, because if you recall here, right, these are crypto addresses. I have no idea who that belongs to, and nobody does. And billions and billions of dollars a day are moving around anonymous accounts, but those could be criminals. They could be drug dealers, they could be money launderers, they could be terrorists, or they could just be some guy like me who's just trading money and doing his own thing completely legally. Nobody knows. So some people push really hard to make things more anonymous. There are entire cryptocurrencies. One is named Monero, that's designed so you can't trace it, and it's completely anonymous. Others have been completely, like Tether, for example, the opposite of anonymity, where everybody has to be registered and everyone has to show their documentation and prove who they are before they can trade the cryptocurrency. So it's completely transparent. And there's, again, a lot of debate. So some opportunities, as students and maybe as entrepreneurs, you guys are always looking for new things to play with. New consensus on risks. How do we agree that the transactions are what they are? How do we agree that things are correct? What happens if I'm checking transactions, you're checking transactions, and the internet goes down for 5 minutes and comes back? Now we have different ledgers. How do we decide who's correct and how do we agree? A lot of work's been done on those, but there's always more work. All right, anonymity. Do you want to be anonymous or do you want to be compliant with traditional regulatory stuff? You can choose a side and you can do work on either one of those. There's a lot of work to be done. Faster transaction processing, like we talked about. There's a lot of work you can do on that, whether they're probabilistic models or graph models and things like that. Lightning Network was something done on Bitcoin. And then there's something called layer 2 chains, where if you remember a transaction, the block has about 200 transactions, but a transaction can be unlimited. So I could have an entirely separate blockchain with millions of transactions, do one big checksum of all of those, and stick that into one transaction on the Ethereum chain. So now I can have a whole separate blockchain running much faster and more efficient things that only needs to send summary updates over here. Those are called layer 2, and there's a lot of work being done on that. Financial derivatives, something that's near and dear to my heart, are new financial models as far as time value of money, basically putting price on risk, putting price on the time of money, quantifying levels of risk in trade. How do you collateralize assets and debt and interest and loans and all that stuff? Something called non-delta 1 derivatives is a very big open area for research. A derivative is a financial product that depends on some underlying asset. Traditionally, there's a variety of them. Delta 1 means that when the asset goes up, they move 1 to 1. It's monotonic. People in finance need things that have an exponential or a curved value function. Options, if anyone's familiar with options, puts and calls are one category of those. Very few of them exist in cryptocurrency, but things that are not, or financial instruments that do not move monotonically with the price of the cryptocurrency, there's a huge demand for those, but they're very difficult because you have to price risk, and that's hard to do with anonymous parties. But people are working on it. Tokenizing assets is always interesting. People are starting to look at, well, if I'm going to buy a flat, why do I need all the paperwork from the government? Why not just have a certificate on the blockchain? It's probably, a better backup of data than whatever database is in the government office, or your car, or your watch, or a bottle of wine, or whatever else you want. You can tokenize assets. So in-game and cross-gate items we talked about briefly. Energy use is an opportunity, right? Mining uses a ton of electricity. Can you come up with more efficient ways to do that? And that probably ties to consensus algorithms. And of course, because we're a university, the last area is education, right? So many people don't know about cryptocurrency yet, and don't know how it works, and don't know what to do with it, which means two things. One, they're missing out on a lot of really good opportunities to make lives easier and better. And two, they're much more likely to be victims of fraud. So there's a huge amount of work to be done in educating the public and educating students such as yourselves to innovate new things. But it's a wide open field. So with that, we've got a few minutes left. Let's do some Q&A. Hopefully you guys have some good questions for me. Oh, and so that's my email. You guys are welcome to contact me if you want.
Questions? Yes.
Oh, please.
Thank you so much for the wonderful presentation. My name is Eric, and I just have a couple of really stupid questions. Our students are really interested in learning the nuts and bolts, the nitty-gritty details of blockchain construction.
Okay.
Like, I give you some data, and then first of all, you have to validate the data first before you mine the data into the block. And then you have to wrap the SHA-256, the encryption function, the helper function, things like that, and then do a genesis block, and then all that jazz.
Correct.
Maybe you can teach those, in the course. And also the other thing that our students really want is cryptographic details, like how to generate the key pair using encryption algorithm, public key, private key, and also to use a modular arithmetic to look at the encryption function. You have to learn how to manipulate the modular arithmetic. Yeah.
Sure. Those are
really want to learn those. Yeah.
Those are good ideas, and we should definitely delve into those. No time in this lecture, of course. But how the internal pieces work is important. I agree. So thank you. Good suggestions. But you're right. Modular arithmetic and the cryptographic stuff is interesting. How the checksums work is interesting. How to construct actual transactions in blockchain is interesting. Of course, people have to then learn how to code a little bit. And I don't know the level of Python or Golang in the department, but well, we can teach if we need to.
They're really good at Python.
Oh, we can do it in Python then. Python works. You guys, just quickly, show of hands. Who here can code in Python? Two. So everyone whose hand is down, you should probably do some homework because you're gonna get in trouble.
We also accept the classes for TPG. These are RPGs.
Oh, okay.
So TPGs, they're not here.
Okay.
So,
okay, good.
Yeah, these are the PhD students.
Okay.
So the course actually for master students.
Okay. Easy to do. Anybody else? Some questions? Don't be shy. We have time. Yes. Good question. There's a few places. There are some online websites that have some historical data. If you want live data, there are two websites you can go to. There's blockchain.info, will have Bitcoin data. And Etherscan, I forgot if it's .com or .info, ETHERSCAN will also have the blockchain historical data on it. If you want to do a proper stats project, though, they're not going to give you a lot of data. If you want deeper data, you need to run your own node and then query the data yourself. They all have some limits on how much data you can query, and it will come in probably an inconvenient format.
Are there high frequency data? What was the frequency?
Well, the Bitcoin blockchain updates every 10 minutes, and the Ethereum blockchain updates every 15 seconds. So it happens in batches. So if you want to go back however much in time, there'll be a batch. Every 15 minutes will be from, I don't know, 100 to 200 transactions with the checksums and the various pieces to it, but it's there. Yes, in the back.
Thank you for the presentation. My understanding is that this focus on how to introduce a new system, like the economical system. It's more about finance. But my understanding is that blockchain techniques are far-reaching, so they can also be related to metaverse. So, do you also have any thoughts on that?
Absolutely, and good question. It's a question of semantics, right? The blockchain is just a database. It's a ledger, right? It keeps track of some accounts and some values. And that could be finance, it could be something else. Now, what you call finance is also semantics. The metaverse is very trendy right now, although it doesn't exist yet. And in the metaverse, if I have my car, my home, my avatar, or anything else, yes, I own those things. The blockchain keeps track that I own them. Is that finance? I'll let you decide on the definition. But it's the same thing. At the end of the day, you just have to think about it as a slow database. And the database generally keeps track of some party, some person with an account, and some assets they own. And then it lets you do some things with those assets, transfer them, loan them, whatever that is. That could be money, that could be a sweater in the metaverse, but it's just a database of things tied to accounts.
But this database will keep growing
Yes.
and growing, and eventually will absorb, it's unmanageable. Right?
Yes, that is a huge problem, which is what we were talking about when I talk about block size, right? What do you do when it gets so big? So people come up with a lot of innovative solutions of having sub-databases and then storing summaries of those in the central blockchain and sub-databases. And there's a lot of work being done, because you're right. Otherwise, it becomes unmanageable very quickly, or it will eat all the computing power in the world, and that's a real problem.
Yeah, and also I think you point a very important issue is most of the blockchains or whatever is in the Amazon, Google cloud.
Yep.
And it's just become centralized, as you said, and it's big deal, right? It's a big issue.
We had a problem recently. If anyone looked, the price of Bitcoin dropped a bunch a few weeks ago, because a lot of the mining equipment, they set up mining computers in Kazakhstan because it's very cold and the electricity is very cheap, and it's close to Asia where a lot of the cryptocurrency stuff happened. There was some political unrest there. I don't know the details, and the government pulled the plug on the internet. So 20-something% of the Bitcoin mining systems disappeared. They went offline, and that killed the price. So to your point, centralization is a problem. In a perfect world, everybody would run a little Bitcoin node in their flat so that there's hundreds of millions, and then it's decentralized. If anyone's curious, you can set up something called a Raspberry Pi, I don't know, maybe 2,000 Hong Kong total. You could run your own Bitcoin node. If you're interested, I'm happy to help you. Could run one here if the department wants one. Anybody else? Last chance? Okay, well, if anyone's interested, you can contact me there if you have more questions, and hopefully we'll have a course this summer where we can go deeper into some of the topics you care about. Thank you.
Thank you very much.